Hello, this is Dr. Peter Gardell. I will be demonstrating the use of the anterior overlay from Dental CAD products. In this case, the individual had two central incisors damaged in a fight. This case will be done in database. The virtual model you can see is going from cuspid to cuspid. We have plenty of information on the adjacent teeth to help with the orienting of the anterior overlay in a consistent manner. With the tools available to us in our CAD/CAM software, we will be able to manipulate the virtual model by, in the case of the CEREC, depressing the left mouse button and rotating the trackball. We can change its pitch, which yaw. Then by depressing the right trackball button and manipulating trackball, we can move the virtual model in its entirety. Once we have the virtual model in a facial orientation, we can apply the anterior overlay. The first thing that we look for is the buccal aspect of the cuspids to align with the outermost vertical lines on the overlay. This will be the basis for the golden proportion of all restorations of the anterior teeth. The other important landmark is the horizontal lines, which should be aligned with the interpupillary line of the patient. The goal of the anterior overlay is to give us the ability to transfer some of the reference marks and landmarks that we use in our traditional rehabilitations to the CAD/CAM system. The interpupillary line is important since it is the basis of correct incisal angle, incisal length, and it will minimize the chance that we'll have a midline cant with the final restorations. By use of the zoom tool in your CAD/CAM system, by enlarging or shrinking the virtual model, we can use this to align the buccal aspects of the cuspids with the outermost vertical lines on the anterior overlay. This is the cornerstone for creating the golden proportions. Once you are happy with the position of the overlay over a virtual model, a few quick marks with a erasable marker will aid in the reproducible placement of the overlay for the subsequent restorations to be done. When we have these larger virtual models, a lot of the times we will have to correct the insertion angle. At this stage, it's also good to rotate the model so your labial of the preparation is lining up with the labial marker on the screen, and will allow the software to generate a better proposal for you. It will also aid when manipulating the proposal with your positioning tools, allow you to move it in a true labial, true lingual, true mesial, true distal direction. After the software has generated the proposal, you will manipulate the virtual model back to a straight-on facial shot. This is where the marks that were placed earlier are going to help you realign the virtual model onto the overlay. By using the landmarks that are available on the overlay, we will now be able to modify the proposal that was rendered. We will be able to look at the width of the restoration, the length of restoration, and it will give us a ratio of what it should be compared to the other teeth in the dentition. By using these circles, we will be able to create our line angles that are complementary to the other teeth in the arch. And then the perpendicular center line to the interpupillary line, the horizontal line, will give us a great guide to minimize the chance that there will be a midline cant with the final restoration. After the first proposal has been manipulated and refined to your satisfaction, we will use the quadrant function to begin the designing of the second restoration. Quadrant mode in the Xeric software will open a second window. In this second window, a new virtual model with the first proposal virtually seated will be seen. It will go through these steps automatically. After it's done with the proposal, you'll go back to the first proposal window, mill preview window, and you'll be able to mill that restoration. This will then allow you to go and design the second restoration. When designing the second restoration, the first step will be determining the center of the virtual model. This step is important since when we are manipulating a virtual model by depressing the left trackball button and rotating the trackball, it rotates around a center point. This center point is determined at this step. It is important to pick a common center point when designing all the restorations. It will ease the manipulation of the virtual model and allow for easier placement of the overlay. After marginating the restoration, you will be asked to correct the insertion angle. At this step, as you did prior, it is important not only to look at the line of draw, but to rotate the virtual model so your labial of the preparation is pointing towards the labial marker on your Xeric screen. After the software renders the proposal for the second restoration, it is important to evaluate the arch form of the restoration. A way you can do this by using the overlay as a tool is to manipulate the virtual model so you have the distals of the cuspids lining up with the horizontal lines. It will give you a good appreciation for the way the facials are in relation to one another, much like when we're doing a full denture wax up and looking down from the incisal. The model can be rotated by depressing the left trackball button and rotating the trackball, and moving the whole model in its entirety by depressing the right mouse button and using the trackball. After the arch form has been evaluated and adjusted if needed, the model can be rotated back to where it is from the labial angle. Using the marks that we have placed on the overlay when we designed the first restoration, we can get the overlay to be in a consistent position over the virtual model. We will now be able to evaluate the angulation of the restoration, the incisal line angles, the width, the length, and ever important, evaluate both restorations to see if there is any midline cant. After the refinement of the proposal is completed, we can send this restoration to mill. Since this case we were doing 2 restorations, we were complete. If we were doing more restorations, we would have to go through the steps of doing quadrant function as demonstrated prior.